Hey everybody, it's Mr. Mac again. It's a wonderful day here at my house, but I've got a lot of work to do before I can hit the pool because I've got to walk you through net force. So start from the top of your notes and let's work our way down. First thing we want to know is what is a net force? That's just a fancy physics way of saying adding two forces together. Another way of saying that is just what are the sum of the forces? What's the total force also? So let's take a look at some quick examples to give you an idea. Now, our basic rule is we need to know which direction the forces are being applied. In this case, we've got a game of tug of war going on with two teams. They're pulling in opposite directions. Now, when we pull in opposite directions, we are in opposite directions, and so we're going to subtract these forces. One of these teams on the left looks like they may be pulling maybe 100 newtons of force. The other team is only pulling with maybe 50 newtons of force. So if I was to write that out, it might look something like this. And I would simply subtract those two numbers. I'd wind up with a net force of 50 when they're pulling in opposite directions. Now, and the same thing's happening here. Two elephants trying to pull a log in opposite directions, but this time they're pulling with the same amount of force. We still subtract because they're in opposite directions, and we see that the net force above the log is 0. We saw this in our simulations earlier, so we're seeing the same thing here. Opposite directions. So we subtract those forces. In this case, that force turns out to be 0. Now here we have an example of two people actually pushing and pulling in the same direction. They're not in opposite. Take a look at the arrows. They always tell the story. In this case, the girl is pushing, and you can barely see it, 25 newtons to the left, but the boy is also pulling in 20 newtons to that same direction. Now, when they're in the same direction, we add forces together. So in this case, 25 plus 20 is a total of 45 newtons in the direction of the arrows. Okay? So, in general, write down the rules. If the forces in opposite directions, we subtract them. If they're in the same direction, we add them. Okay, so what we can do is we can change the motion. We just need to be sure we understand what motion is. Motion includes both the speed and the direction. We can also call this velocity. So we change the velocity, it's changing the motion by changing either the speed or the direction. So acceleration, again, is anytime you speed up or slow down or turn left or turn right. Anytime you're doing that, you're changing your speed in a particular direction. We call that an acceleration, just like these cars here. Now, we need to define what it means to have balanced forces and unbalanced forces. If we have balanced forces, that means the net force is 0. Two forces, opposite directions, they cancel each other out. There's no net force. What that means is there's no acceleration. The motion of the object is going to be constant. That means a constant speed and a constant direction. Likewise, if it's unbalanced forces, the opposite applies. The net force is not 0. It can be greater than 0. It can be less than 0, actually. That means that you're accelerating, you're speeding up, or you're slowing down. Your motion is changing. And again, that means you're changing your speed or your direction. So let's take a quick look at some real-world examples here for balanced and unbalanced forces. This is what you should have seen at the bottom of your page, these little scenarios. The first scenario is I've got a box. Me and you are going to be pulling in opposite directions. It looks like we're both going to be pulling with about 100 newtons of force. Because they're in opposite directions, we are going to subtract our forces. So it's going to be 100 minus 100. That equals 0. My net force here is 0. Is that a balanced or unbalanced force? Balanced forces are always a net force of 0. So it's balanced. What's that tell me about my motion? My motion is going to be constant. Now, it doesn't mean I'm not going to be moving. It just means my speed is not going to change and my direction is not going to change either. Okay. Next example. Let's say me and you are pushing a car. Here's my bad picture of a car and my bad picture of you and me, but we're both going to be pushing the same direction. Now, maybe I can only push with 50 newtons of force, you can push with 150 newtons of force. Because they are in the same direction, we're going to add those two together. That's 200 newtons of force. Is that balanced or unbalanced? Well, if it's not 0, that means it's unbalanced. And because it's unbalanced, that means we're experiencing some kind of acceleration. We're going to accelerate. That means my speed is going to change or my direction is going to change. In this case, my speed is going to change. I'm probably going to be pushing off to the right, and my speed of that car is going to be increasing as we go along. Okay, so there's our quick notes. At the very bottom, we want you to do your own little drawing and prediction of what's going to be happening in the situation, whether it's balanced, unbalanced, constant motion, changing motion. Fill that in, and we'll go over that in our next class. So I'm done here. I'm ready to hit the pool.